Number 27. Solid iron 3 hydroxide decomposes to produce iron 3 oxide and water vapor. If 0.75 liters of water vapor is produced at STP, and we have A and B. But before we get into the problem, I always like to start with the balanced chemical equation, because again, we are doing gas stoichiometry here, stoichiometry. So let's make sure that we have a balanced chemical equation. So iron 3 hydroxide. Well, iron is the type that has a +3 charge, and it is bonded to hydroxide. But this is an ionic compound, so the total positive charges have to balance the total negative charges. Well, the name tells us that this iron has a +3 charge. Hydroxide has a -1 charge, so in order to balance all of those charges out, we're going to have 3 hydroxides. Now it's going to decompose to produce iron 3 oxide. Again, that's iron with a +3 charge and oxygen, oxide. But this has a -2 charge. So in order to balance those charges out, I have to have the subscripts of 2 and 3 in there. The other product is water vapor. Alright, now the fun begins. Let's balance this bad boy. So initially, I could start out by putting a 2 in front of this first iron. That would balance my irons, right? But then I would have 6 oxygens and 6 hydrogens to deal with. Now I could then put a 3 over here. That would give me 3 oxygens plus 3. That would give me 6 oxygens as well, and then that would give me 6 hydrogens. Actually, I think that's a pretty good idea. Let's go with that. All right. So I have 2 oxygens on each side. I have 2 irons on each side. I have 3 sets of hydroxide, so that's 6 oxygens. 3 here, 3 there, so that's 6 oxygens on the right side as well. 6 hydrogens, and got 6 hydrogens right there. Okay, so we're all balanced up. So it's a ratio of 2 to 1 to 3. Cool beans. Also, as I start to read part A, it says how many grams of iron 3 hydroxide were used. Goodness gracious. And also how many grams of iron 3 oxide are produced. That means at some point I'm going to have to use the molar mass of both of these things. Ugh. So again, once I get into the flow of doing crosshairs, I don't like to stop to balance equations or calculate molar masses, so I like to do them right up front. Okay. Now I have the formulas for each of these, so I can just plug these into the calculator. Now the periodic table tells me that iron has a mass of 55.85, but I'm going to have to add to it the mass of 3 oxygens and the mass of 3 hydrogens. Okay, so I know that iron 3 hydroxide is going to have a molar mass of 106.88 grams per mole. I can use that later. But I'll also do iron 3 oxide to help myself out a little bit later. You always want to do future self you a little bit of a favor. So 55.85. There are 2 of those. And I'm going to add that to the mass of 3 oxygens. And I come up with a pretty large mass, 159.7 grams per mole. And we're ready to set up some calculations. So we're starting with 0.75 liters of water vapor. So let's start with 0.75 liters of water. But we're going to have to convert out of liters of H2O. We can go into moles of H2O very easily because we're at STP. And if we're at STP, we know that 1 mole of any gas occupies a volume of 22.4 liters. So liters of H2 will cancel. I'll be in moles of H2. Then I can use the mole to mole ratio of water to this iron 3 hydroxide. Then that'll cause the moles of water to cancel. I'll be in moles of the iron 3 hydroxide, and I can use, you guessed it, the molar mass that I figured out ahead of time to go into grams of that iron 3 hydroxide, because moles will disappear after that. Perfect straight line. Alright, let's put these numbers in. For every 1 mole, I have 22.4 liters. I have a ratio of 2 of those for every 3 of those. And for every 1 mole, 106.88 grams. So let's do some calculating. 0.75 times 2 times 106.88 divided by 22.4 divided by 3. And I come up with, let's see, I need 2 sig figs right here because the question gives me 2 sig figs. So I'm going to have that 8 turn that 3 into a 4. So 2.4 grams of iron 3 hydroxide. We're going to do essentially the same setup, but this time for iron 3 oxide. So start with, like I said, 0.75 liters of H2O. I'm going to convert out of liters into moles. That way I can use the mole ratio, start talking about what the question wants me to talk about. Here's my mole ratio, H2O into the iron oxide. And then I'll use the molar mass of iron oxide, iron 3 oxide. Liters cancels with liters, moles of water cancels with moles of water, then moles of iron oxide cancels with moles of iron oxide. So every 1 mole, 22.4 liters, because, again, question told us that we're at STP. Again, at STP, 1 mole of any gas equals 22.4 liters. Let's see. That's a 1 to 3 ratio. And then 1 mole of this, 159.7 grams. Alright, let's do some calculating. 0.75 times 159.7 divided by 22.4 divided by 3. Let's see. Again, oh, we got a little shine there. Again, 2 sig figs, right? Because the question gave us 2 sig figs to start with. So that 8 is going to turn that 7 into an 8. So I'm going to go 1.8 grams of iron 3 oxide.